All right, guys, I want to show you one quick example before you come into class tomorrow. I want to start off with this problem that what we are going to try to do is to write the equation of an ellipse given these two pieces of information. So what I'm going to do is I'm going to graph these pieces that are given to me to help me figure out the equation of the ellipse. All right, guys, as you can see here, I've got the vertices. I've got one at -7, -3, and I got another one at 13, -3. And I've also got my focus points. Now, the plural of focus is foci. Now, some people say that wrong, but it's not that big a deal. It's called a foci since there are two of them. Now, the fact that my vertices run left to right, therefore my major axis is horizontal. So I know that if I move this up, I know that the major axis is horizontal, which tells me that the fact that if it's horizontal, I know that my bigger number is going to be underneath the x term. So a squared, it is the bigger number, and it's going to be under the x value, under the x. Now, to start off this, I need to figure out, well, where is the center of my ellipse? Well, I'm going from -7 all the way to 13. And what I basically want to do is to figure out the average of those two numbers. Well, if this is -7 and this is 13, well, if I do the average of those two things, I'm basically going to get 13 minus 7, 6. Divide by 2, that means I have an x-coordinate of 3. So my center is right here at 3, -3. Now, how does that help me? Well, if I know the center, then I can go ahead and do 2 parentheses, put a plus sign, and I know that it's going to be opposite, so x minus 3 and y plus 3. And I know if it's an ellipse, it should be equal to 1. And this is where I told you guys to take my word for 1. The equation in your book is insane. All right, so the distance, from the note card, the distance from the center to your vertex is the value of A. And knowing that's the value of A, remember, one of these is going to be an a squared, one of these is going to be a b squared, but we already know the a squared is the bigger number, and it's underneath the x value. So this is technically my a squared spot. By default, that would be my b squared spot. Well, I'm going from 3 all the way over here to 13. That's a distance of, you can count it if you want to. I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or I could just subtract, obviously. So if a is 10, then a squared would make this 100. Okay, so far I'm good to go. Now, the problem is I don't know what b is. I don't know the value of b. However, I do know that the distance from the focus to the center is c units. Well, the distance of that is 1, 2, 3, 4, 5, 6, 7, 8. So here's the deal. This is why I gave you this on the note card. If a is 10 and c is 8, then what I can do is use this formula, which is on your note card. C squared equals a squared minus b squared. And I can plug in these values to solve for c. Well, we know that c is 8, so c squared is 64. We know a squared is 100. And all I got to do now is subtract 100 from 64. And this is going to give me -36 equals b squared. And all I got to do now is divide both sides by -1. And so we get a value of b squared is equal to 36. And now notice I can plug that in. And we've just found the equation of the ellipse, given that information. Man, these problems are fun. I can't wait to see y'all tomorrow in class. Peace out.